A programming language is a standardized communication technique for expressing instructions to a computer. Like human languages, each language has its own syntax and grammar. Programming languages enable a programmer to precisely specify what data a computer will act upon, how these data will be stored or transmitted, and precisely what actions to take under various circumstances. There are different types of programming languages that can be used to create programs, but regardless of what language you use, these instructions are translated into machine language that can be understood by computers. A high-level programming language is a programming language that is more user-friendly, to some extent platform-independent, and abstract from low-level computer processor operations such as memory accesses. A programming statement may be translated into one or several machine instructions by a compiler. Examples of high-level programming language are Java, C, C++, BASIC, Fortran, C#. Low-level assembly languages are similar to machine languages, but they are much easier to program in because they allow a programmer to substitute names for numbers. Assembly languages are available for each CPU family and each assembly instruction is translated into one machine instruction by an assembler program. Programmers do not sit down and start writing code right away when trying to make a computer program. Instead, they follow an organized plan or methodology that breaks the process into a series of tasks. Here are the basic steps in trying to solve a problem on the computer. Good programmers define problem definition. They analyze problem before they start coding. They design algorithm representation the problem in pseudocode or flowchart. And finally, coding and debugging. In order to understand the basic steps in solving a problem on a computer, let us define a single problem that we will solve step by step as we discuss the problem-solving methodologies in detail. A programmer is usually given a task in the form of a problem. Before a program can be designed to solve a particular problem, the problem must be well and clearly defined first in terms of its input and output requirements. A clearly defined problem is already half the solution. Computer programming requires us to define the problem first before we even try to create a solution. How to analyze this problem in programming? After the problem has been adequately defined, the simplest and yet the most efficient and effective approach to solve the problem must be formulated. Usually, this step involves breaking up the problem into smaller and simpler sub-problems. For instance, determine the number of times a name occurs in a list. Next, design the algorithm and represent it in flowchart or pseudocode. Once our problem is clearly defined, we can now set to finding a solution. In computer programming, it is normally required to express our solution in a step-by-step manner. An algorithm is a clear and unambiguous specification of the steps needed to solve a problem. It may be expressed in either human language, for example, English, through a graphical representation, like a flowchart, or through a pseudocode, which is a cross between human language and a programming language. Coding and debugging. After constructing the algorithm, it is now possible to create the source code. Using the algorithm as basis, the source code can now be written using the chosen programming language. Most of the time, after the programmer has written the program isn't 100% working right away. The programmer has to add some fixes to the program in case of errors or bugs that occurs in the program. This process is called debugging. There are two types of errors that a programmer will encounter along the way. The first one is compile time error, and the other is runtime error. Compile time errors occur if there is a syntax error in the code. The compiler will detect the error, and the program won't even compile. At this point, the programmer is unable to form an executable that a user can run until the error is fixed. Forgetting a semicolon at the end of a statement, or misspelling a certain command, for example, is a compile time error. It's something the compiler can detect as an error. Compilers aren't perfect, and so can't catch all errors at compile time. This is especially true for logic errors such as infinite loops. This type of error is called runtime error. For example, the actual syntax of the code looks okay. But when you follow the code's logic, the same piece of code keeps executing over and over again infinitely so that it loops. In such a case, compilers aren't really smart enough to catch all of these types of errors at compile time, and therefore, the program compiles fine into an executable file. However, and unfortunately, when the end user runs the program, or even their whole computer, freezes up due to an infinite loop. Other types of runtime errors are when an incorrect value is computed, the wrong thing happens,